This is my presentation on bonding polyatomic covalent ions. A polyatomic covalent ion is a group of atoms that are held together by covalent bonds that also have an overall charge that is either negative or positive. These ions must also follow the rule of octet. For the rule of octet, we know that noble gases have 8 valence electrons, meaning that they are stable. Other non-noble gas elements bond with each other in order to try to simulate this feeling of stability. So now that we know what a polyatomic covalent ion is, let's go over their Lewis dot diagrams with an example. This example is SO3 with a -2 charge, and for right now we are going to leave this -2 charge alone and focus on the rest. Step 1 is to find the valence of each element, which can all be found on the periodic table. And from the periodic table, we know that sulfur and oxygen both have 6 valence electrons. But since there are 3 oxygens, we have to multiply this number by 3, making 18. Step 2 is writing out the Lewis dot diagram. And as you can see here, we have the Lewis dot diagram for both elements, except that oxygen's number of electrons must be multiplied by 3, meaning that we have sulfur's 6 plus oxygen's 18, making a total of 24 electrons that must be represented. Step 3 is time to bond. So now that we've figured out how many bonds there should be, we have to draw the diagram. And because there are 3 oxygens, we know that sulfur will be in the middle, with the 3 oxygens surrounding it. And there will be at least 1 bond between each of these. Now we have used a total of 6 electrons, meaning that we have 18 that are left to be represented. We can draw the rest around each oxygen. But, as you can see here, the element sulfur does not follow the rule of octet, because instead of having 8 valence electrons, it only has 6. This means that these atoms are in need of 2 more electrons. Step 4 is solving the problem. Since we have run into a problem with the amount of electrons needed for these 2 elements, they are going to borrow some from another atom. This means that 2 electrons will be added to the already existing 24, making 26 electrons that need to be represented in the diagram. This borrowing now makes it so that the elements sulfur and oxygen together have a negative charge of 2. Step 5 is writing out the final version. And so as you can see here, we have the diagram where we left off. And now we can draw the 2 last electrons, allowing sulfur to follow the rule of octet. And this is the Lewis dot diagram for sulfate. Thank you for watching.